In this video, I'm going to explain you about the coplanar distribution. They have given you a theorem, so we can do a two-dimensional mass distribution. So since we are taking a two-dimensional mass distribution, d and e will be taken as 0. Okay, so we have ox and oy as our original axis, and we are rotating that axis to an angle theta, and we want to find what is that angle theta. So that angle theta, we have to prove that it is tan to theta equal to 2f b minus a, and also we want to find the maximum and the minimum value of the moment of inertia at O through the principal axis. Okay, so we are taking at the principal axis what is the maximum and the minimum value. And also or they can ask you the question for a two-dimensional mass distribution. They might ask the question as, for a two-dimensional mass distribution lamina, find the maximum or the minimum value of the moment of inertia passing through O, taking attained at the principal axis. So we are taking attained through the principal axis at O. So we have the body here. So suppose I take this as my rigid body. So this is my rigid body. So this rigid body, originally it is, the axis is x here, this is O, this will be y, and this axis to the rotation here is taken as, this is x dash, this is your y dash. Okay, so this point I'm taking p x y, and this is the coordinate of p with respect to ox and oy, and the coordinate of p with respect to ox dash and oy dash is nothing but x dash y dash. So this distance is taken as y dash, and this distance is x dash, x. This distance is y, and this distance is x. So this perpendicular distance here is taken as y dash, and this perpendicular distance will be x dash. Now our aim here, we know the moment of inertia about for a two-dimensional body is about the x-axis is given by summation my square, and b is the moment of inertia about the y-axis. This is given with summation mx square, and f is the product of inertia about the xy plane, so this is given by summation mxy. Now we'll try to find the equation of OX. So how to find the equation of OX? So equation of OX is y minus 0 divided by x minus 0. Okay, x minus 0 equal to the slope of this line. Okay, so slope of the line is given by tan. So the angle from here to here, the rotation, whatever is taken as theta. So the slope of this line OX is nothing but tan theta. So we get here y equal to x tan theta. So this can be written as x sine theta by cos theta. Okay, we can write as sine theta by cos theta. So we get here y cos theta equal to x sine theta. So this can be also written as, bring this one to this side, so y cos theta minus x sine theta. Okay, this is equal to 0. Now if you want to find the equation of oy dash, you replace theta by theta plus pi by 2. Theta plus pi by 2. So if I replace this theta by theta plus pi by 2, so this is the equation of oy dash. So we get here y cos theta plus pi by 2 minus x sine theta plus pi by 2 equal to 0. So this you give you, this is nothing but in the second quadrant, so cos is negative, so we get minus cos theta, minus sine theta. It is an odd multiple of pi by 2, so cos will change to sine, so we get minus y sine theta, and this will be, sine will be positive, we get minus x cos theta, which is equal to 0. So you can take common minus, so we get y sine theta plus x cos theta, which is equal to 0. So that is the perpendicular distance. So this distance from here to here I'm taking PL, and this distance I'm taking as M. So I want to find what is PL and PM. So PL is given by, what is the perpendicular distance here? PL is nothing but, it is y dash, which is given by the perpendicular distance from OX dash. What is the perpendicular distance from OX dash? So this is the equation of OX dash. From here we are trying to find the perpendicular distance. So we'll have here y cos theta minus x sine theta, square root of cos square theta plus sine minus sine square minus, okay, here will be plus, this will be minus sine theta whole thing square. So this will give you y cos theta minus x sine theta. So we are getting here this, and pm, we try to find pm. So pm is nothing but x dash. Okay, so that is the perpendicular distance from OY. So what is the equation of OY? The equation of OY is this. So we have here y sine theta plus x cos theta divided by square root of sine square theta plus cos square theta. So we get here y sine theta plus x cos theta. Now we'll try to find the moment of inertia about IOX dash axis. So we'll try to find the moment of inertia about the IOX dash axis. That is one summation m y dash square. So we have this summation m y dash. So what is our y dash? Y dash is y cos theta minus x sine theta whole thing square. So if I square this one with the formula a minus b whole thing square, I'll get here to be nothing but, I'll get here as cos square theta summation my square plus sine square theta summation mx square minus 2 sine theta cos theta summation mxy. So we get this. Now this is nothing but, this is a. Okay, so this will get us what? This is a, this is b, and this is f. And sine 2 sine theta cos theta is sine 2 theta. So we get here as, this will be your a cos square theta plus b sine square theta minus f sine 2 theta. Now we'll try to find what is the moment of inertia about OY dash axis. Okay, OY dash axis. So that is given by summation m x dash square. So summation m x dash we got as x dash, what we got here, x dash we got as y sine theta plus x cos theta. So we got here y sine theta plus x cos theta whole thing square. Okay, so we are getting this. So if I do the, here we get as sine square theta summation my square plus cos square theta summation mx square plus 2 sine theta cos theta summation mxy. Okay, so we have this equal to, this will be a, so a sine square theta plus b cos square theta, this is sine 2 theta, so this is f, so f sine 2 theta. I will try to find the product of inertia about the x dash and y dash plane. So x, here we get x dash y dash, product of inertia, that is nothing but summation m x dash y dash. So we have summation m x dash is y sine theta plus x cos theta. Okay, y dash is this, and x, this is x dash, y dash is y cos theta minus x, okay, y cos theta minus x sine theta. So this is your x dash, this is your y dash. So you multiply this, after multiplication you get as sine theta cos theta summation my square minus sine theta cos theta summation mx square minus sin square theta summation mxy plus cos square theta summation mxy. So we get like this. Okay, we get here this way. So we are getting this. So this is equal to what? This is A, this is B, this is F, this is F. So we get here A sine theta cos theta minus B sine theta cos theta. Okay, and this from here, these two are same, so I can take common. So if I take common this one, I get here plus F. This is F, so plus F cos square theta minus sine square theta. Okay, so we have this. So this can, here also I can take this two common. So here we get A minus B. So suppose I give here 2, so this will be 2 sine theta cos theta plus, this is nothing but cos 2 theta. Okay, so this is cos 2 theta. So we have here, this is sine 2 theta, so we get A minus B by 2 sine 2 theta plus F cos 2 theta. F cos 2 theta. Okay, now since this IOX dash and IOY dash are the principal axes, the product of inertia should be 0 above that plane. So the product of inertia should be 0, so we'll take this IX dash Y dash to be 0. So if I take this one to be 0, what I get here? A minus B by 2 sine 2 theta plus F cos 2 theta equal to 0. So this, you go this side, so we get A minus B by 2 sine 2 theta equal to minus F cos 2 theta. Then we'll multiply with minus. So if we multiply with minus, this become as B minus A by 2. Okay, so we get here B minus A by 2. This will be sine 2 theta. This is F cos 2 theta. So this cos you bring this side, this you multiply here, and this you multiply here. Then we get here as, okay, we get here as tan 2 theta equal to 2F B minus A. So the rest I'll explain in the next video. Thank you.